It could be hollow.
Your head, hollow.
Oh yeah?
Yeah.
That's not hollow.
What the heck? That's your shoe. I like grabbed your shoe because I thought it was the
This.
Because I was like, what the? I felt this all felt really close.
Okay, we're going to start here. This is one more indefinite integral. This is example 6. What page is this? Great question. 462. Page 462. Okay. So this is the last example that we should have gotten through yesterday, and we just didn't. We worked really hard yesterday and just didn't get it there. So we're going to start with this one. This is another indefinite integral. This one's kind of a special case. There doesn't seem to be any substitution that I can do, right? Yesterday we looked at, I want to take out maybe a composition of functions or something like this, and I want to name a specific function u, and then we're going to operate in terms of u instead of in terms of x. Do y'all remember doing this yesterday? Okay. Here, it doesn't look like there is anything I can take out.
Can you split tangent?
You could split tangent. Okay, so now I have sine x over cosine x dx. Great. Really smooth move. But the problem here is now it's a quotient, and I still don't have rules for differentiation or anti-differentiation. But I can use my u substitution here. Remember that it's helpful to call u a function such that its derivative is seen in the problem.
The derivative of sine is cosine.
Okay, the derivative of sine is cosine. The derivative of cosine is sine. So which one do we want to do here?
Probably cosine.
Okay, we want to cancel. We want to be able to cancel. Okay, you could try both. I'll steer you kind of in the right direction here, and let u be cosine. Okay, let u, just for sake of time, but you could definitely try both. Let u be cosine of x. That makes du, what's the derivative of cosine? What'd y'all say? Negative sine dx. Which means dx is going to equal du over negative sine x. Okay, so really, really quickly, what would have happened if I said let u be sine x? Don't write this down. Okay, if u is sine x, then du is cosine x dx, and then I end up dividing by cosine, which if I plug that in here, that puts me 2 cosines on the bottom. It's not going to cancel. Versus if I plug in this guy, the sine and the sine are going to cancel. Okay, that's why I would go one way over the other. Test and check. Okay, don't try to remember that. Go away. Okay, so now we can plug back in. We're going to have equals the integral of sine x over u times, and instead of dx, we're having du over negative sine x. You'll see where this is going? Sinks are for dishes. Cancel sine x. Got 1 over u du. Negative 1 over u du. I could call it u to the negative 1. Remember that? Okay, so let's anti-differentiate here. Let's go u to the negative 1 over, add 1 back. So it's going to be u to the 0 over, oh man. Don't like. Are we stuck? There's nothing we can do? Come on, young students. I told you this. You're going to make this move, and you're going to spin a web, and you're going to get something undefined, and then you're going to just freak out. And then you're going to remember The antiderivative of 1 over x is natural log. Good, Sebastian. This is a natural log. This is in your table of anti-differentiation rules, right?
Yeah.
The derivative of natural log is 1 over x. So the antiderivative of 1 over x is the natural log, guys. You're going to spin this web. Promise. You're going to call it u to the negative 1. You're going to try to do the thing. You're going to divide by 0, and then you're going to wet your pants. Remember, it is natural log. Go backwards. Go backwards. Get there. Okay? So we've got negative natural log u plus c. Why absolute value, guys? Can't take the natural log of a negative number. So we protect that. Okay? And then last thought here. Oh, 2 last thoughts. We have 2 of them.
Plug in for you.
Go back in with the girl you brought. So there's going to be natural log of cosine x plus c. Okay, almost done. Almost done. When I have a negative or any coefficient in front of natural log, let's say I had 2 natural log 2. This could have been an exponent. It could have been written as the natural log of 2 squared or the natural log of 4. Okay, this is a rule that we had when we were manipulating logarithms last year. So this negative in front of natural log could swing up here as a negative 1 on cosine x. Okay, alternatively written, natural log, not limit, goodness gracious, of cosine x to the negative 1 power. In other words, 1 over cosine, natural log of 1 over cosine x plus c. What is 1 over cosine? Nope, secant. Natural log of secant x plus c. You need to add this to your antiderivatives. The integral of tangent is the natural log of secant x plus c. The derivative of tangent is the natural log of secant x plus c. Yeah. This is how we handle indefinite integrals. Notice that all of our answers, if you look back, example 1 through this one, example 6, have plus c. All of them have plus c. Okay? Today we're going to look at definite integrals, where I have limits of integration. Okay? We do have plus c. We do have limits of integration. What am I saying? Just shut up and turn the page.
I don't know if you can answer this right now. Can you have an integral of an integral?
Can you have an integral of an integral? Yes. Yes. That will happen to you. Cal 3. Hang on tight. You'll love it.
What did you say?
In Cal 3, he asked if you could integrate an integral. Yes. You can have 3 of them. Yes. Pretty cool. You could keep going. He could keep going. I don't have any interest in doing that. Example 7. All right, so it says evaluate on 1 to 3. So now we know it's a definite integral. It has boundaries. Evaluate on 1 to 3, x squared plus 1 cubed x dx. X squared plus 1 cubed x dx.
They like x squared plus 1 a lot as a term.
As a function?
Half of
Cool.
the-
Okay, so watch this move. We're going to let u be what? x squared plus 1. That's great. So du is going to be 2x dx. Dx is ending up being du over 2x. Our x's are going to cancel. I want to introduce you to a whole new world. And I mean that quite literally. A whole new world. I need you to think like Magic Carpet Ride, Aladdin, Jasmine, the whole setup. A whole new world. Okay. If I wasn't sick, I would go full solo here. We don't have Becca, or we could count on it. You can switch dance partners. And yesterday, we really emphasized the importance of changing back at the end of the night, right? But this is a whole new world. We have left the prom. We said goodbye. It is over, it is over, it is over. And there is a new person involved here, you. But in order to evaluate and not have to switch back, because we're over it, right? We're never, ever, ever getting back together. X is gone. Okay? We said goodbye. We said goodbye to the X. Get it? Get it? We said goodbye to the X. So in this new world, we're falling under the world U, okay? But our limits of integration, that 1 and 3, they were in X world. We want to get rid of those, and we want to operate under new boundaries because it's a whole new world.
Look at this.
Do you see this? Okay, so in X world, we had 1. In X world, we had 1. What is that 1 in U world?
Nothing.
Watch. Put the 1. She said nothing. With confidence. Put the 1 in place of X in this U situation. So where X is 1, U is, plug the 1 here. 1 squared plus 1 is 2. So my new limit of integration is going to be a 2. Instead of the 1. It's a whole new world. Oh. We said goodbye to the X. 3 squared plus 1 is 10. So now we're going to evaluate on 2 to 10 instead of on 1 to 3. Now we're free to carry on with U. We don't ever have to go back to our X. We change the whole world. You see? You see? So now we have 2 to 10, and we have U was this x squared plus 1 cubed. So we're going to have U cubed. There's a little x still involved here, but we're going to cancel it when we plug in our du over 2x. Right? He goes away.
So 1/2 times the integral and all that stuff.
Yeah, so we end up with half times the integral on 2 to 10 of u du. What's the antiderivative of u? U cubed. What's the antiderivative of u cubed? I got real excited about this. Antiderivative? Okay, so 1/2 times u to the 4th over 4 evaluated on 2 to 10. I'm going to have 1/2 of 10 to the 4th over 4 minus 2 to the 4th over 4. Right? F of A minus F of B. F of 10 minus F of 2. I don't know 10 to the 4th, y'all. Is that 10,000? Yeah.
Probably.
So half of 10,000 fourths minus 16 fourths. Yeah. $10,000 divided by 4. 2,500. Half of 2,500 minus 4.
1246. Or
2496.
numbers.
half of 2496. $12.48, they all said with enthusiasm. That's the not magic of having a tiny screen. If I had my big board, we would be going on. Any questions here? What happens if you don't change the world?
You get the wrong numbers.
You have to go back to your x's. Okay? After you use, if you plug in these old x values, listen, you stay in U world, but you use your old x values. You're going to be wrong, first of all. That's going to be the worst thing that happens to you. You're just wrong. The second thing is, if you don't change your limits, then you have to go back to your x. That makes life really, really complicated in terms of plugging in later. Notice how really clean my u antiderivative is. It's u to the 4th over 4. That's pretty sweet. My antiderivative, if I have to plug that back in, is x squared plus 1 to the 4th over 4. And now I'm plugging into a composition of functions. It's gnarly. Okay? Your much better option is to leave the x's behind, change worlds, and operate under the new u limits. Do you understand? If you don't, bad things happen. 1, you miss it because you just forgot to change your limits. 2, you have to go back to x and operate under that world, and that gets very, very complicated. Okay, I had a student last year that was like, I don't like changing worlds. I will always go back to x. And then he really regretted that because it's so much harder.
But
Okay?
is it possible?
Yes, but it's so much nastier. Okay, so much better benefit is to leave the x's in the past and move on.
Amen.
Amen. Amen, they say. Here we go. All right. You never knew you would learn so much. How does this apply to my real life? In all the ways. All right, here's the next one. This is evaluate. Not naming names. I haven't known y'all forever. 1 to 2. Evaluate the integral on 1 to 2 of dx over 3 minus 5x squared.
dx on top.
Huh.
We can just move that
Oh,
over.
that's just
right?
1 over.
Right, good. Okay, so they're saying we can just scoot that over. Good. I was worried because y'all didn't recognize the natural log business, but maybe points for redemption here.
Oh my god, yeah, that's natural log. It's gonna be 1 over the thing.
Oh, maybe. Maybe. Bethany's calling it. She says, maybe. Okay, so what do you think? Let's get this thing going. U equals,
3 minus 5x.
okay,
But then it's squared, it's not 1 over x, it's 1 over u squared. I don't like that.
right, so it won't be natural log. Okay, that's fine. What's du?
Oh, 5. Negative 5.
That kind of makes me feel better because I was sitting here wondering what's going to cancel. Negative 5 dx. So dx is going to be du over negative 5. Okay. We'll hold that for in a minute. A whole new world. Yeah, every time. Don't you dare close your eyes. So if x is 2, then u equals, this is evaluated at x equals 2. Then u equals 3 minus 5 times 2, or 3 minus 6, or 10. 3 minus 10. 3 minus 10, negative 7. Okay. And x equals 1, u equals 3 minus 5. Okay. So this guy is going to be evaluated from negative 2 to negative 7.
Isn't that upside down?
Okay, it is upside down. So I want you to read in the textbook. This is example 8 in the book. Read in the bottom, there's a blue paragraph. It says, change the variables. the bounds become reversed in terms of u, that is okay.
Oh, okay.
Okay, so just keep rocking with it. It's going to be fine. It says continue with the fundamental theorem of calculus. So they know that that happened, and they're saying, don't panic. Just keep going.
Why is that?
These are questions I don't know the answer to.
So we don't swap them and make it?
Right, so don't worry about it. Just keep going. Because you're in a whole new world. And so these boundaries are the new boundaries. Obviously. Everything you learned thus far is thrown out. Okay, so we got 1 over u squared times du over negative 5. Could call that negative 1/5 times the integral from negative 2 to negative 7. Y'all want to call that u to the negative 2 now?
Yeah.
I scared you into not wanting to do that because of the negative 1. So what's the antiderivative? U to the negative 1 over negative 1. Add 1 back, divide by the new. On negative 2 to negative 7. I think it'd be helpful if we pulled that negative 1 out and let it cancel with the negative 1/5. So I'm going to pretend now mine says 1/5 u to the negative 1 to the negative, or on negative 2 to negative 7. You want to 1 over u? I like that.
Oh my God, choose the natural.
No.
No, we already
Stop saying natural log, please.
Stop saying natural log.
And you. And then subtract this stuff.
I need a common denominator. I remember one day, like a week ago, I said we had to have a common denominator. And Seth said, but why? Oh, because that's how this goes.
Seth was aghast.
He was. Do y'all remember that? I'm going to make it plus because my negative 2 and I'm minus negative 2. So I'm going to let that be plus. So negative 2/14 plus 7/14. 5/14. And the 5s cancel because I've still got that pesky 1/5 out in front. The signs here. The signs are wonky.
Yeah, we can say we just back 179 for 1 half. You want to plug it back for you?
Right. Because we changed the worlds.
Oh, so
It's a whole new world.
Yeah, the rules don't matter until they do.
What's your question? Why did I not have to plug back in the 1 and the 2? Because, do you remember this step? Can I go back a page?
No, I understand.
We changed the world to 1 to 2 to negative 2 to negative 7.
I do.
When we said if x is this, then u is this. That allows us to not have to go back to x. And we don't have to evaluate under x terms.
We don't want to go back to our x's.
Okay? Hey, look in the middle of page 464. Do you see the red words?
yes.
Cohen, with all of your wonderful reading, read the red.
Change variables, but keep the limits of integration associated with x.
That's a common error. I thought you would start at the...
Say the right words.
Okay, so that's a huge thing that happens. Kiddos will change variables. You'll go to u, but you'll just forget to change those limits. And I'm telling you, you'll get it wrong. Okay, mathematically, it's going to look like you're doing all the right things. You're not going to butt a stump. You're going to be just fine. But then at the end, you're going to have the wrong answer because you did not change the worlds. Right. Okay, last one. Example 9. So the integral from 1 to e of natural log x over x dx.
We're getting into some
This is some shady
shady territory.
territory.
Who came up with this one?
The shady people.
The shady.
So it's a quotient. So we cannot anti-differentiate without doing some u sub. Okay? So what is our substitution here? What do we want to do?
Probably natural log x. Right?
Probably natural log.
We don't want to like make it just u equals x.
What's the derivative of natural log?
1 over x.
Okay. Is that going to
1 over x
cancel?
over- Yeah, 1 over x over x. Maybe.
Okay, so what we're saying here is let u be natural log x. Then its derivative is 1 over x. Hold on. 1 over x dx. Then what? What do I do with that? I've got to solve for dx. So what am I going to do?
Divide by 1 over
Divide by 1 over x, which is to multiply by its... So really dx is x du.
I was right. Everyone said
Cohen was right. Cohen was right. So when I multiply by x, it will end up canceling. So that wasn't a bad move. Okay? You gotta, it takes some guts. It takes some think it through what will actually end up canceling. Okay? If you go the wrong way, just try it the other way. You'll be fine. You'll be fine. It's just trial and error. And if they're both wrong, shut your book and go make a snack.
we've changed the numbers on the number now.
Okay, so when x equals e, u equals natural log e, and my class of knowledge students say natural log of e is
1 or 0.
it's either 1 or 0.
It undoes it, so it's
I
probably
said 1 over 0, and I was like,
See, I said 1 first.
they undo each other.
Natural log of e is 1, young humans. No.
I have a calculator.
When x is 1, u equals natural log of 1, which is... I think my picture is actually backwards here.
That's the one that's a 0.
here's 50%.
Yeah, I told you.
Natural log of 1 is 0.
I would get partial credit
It's
for
nicer than
that.
it was.
That means it goes through
Would you?
No.
1 comma 0 and e comma 1. Okay? Disregard my picture. It's really bad.
Our interval, it's nicer than it was before. Now it's just 0 to 1.
Okay.
That's pleasant.
So we have on 0 to 1, instead of natural log x, we're using u over x times x du. Cancel those. What's the antiderivative?
Of you?
Uh-huh.
U squared.
Mm-hmm. On 0 to 1. So 1 squared minus 0 squared over 2. 1 squared over 2 minus 0 squared over 2 is...
Wait, where did the 2 go? Oh, wait, no, just kidding. I know.
half.
Yay.
Nice.
Yeah, we like half. Are we solid on this, y'all? Besides the fact that we can't natural log values. Natural log of e is 1. Natural log of 1 is
0.
good. Natural log of 0 is
Undefined.
good. Okay.
Booyah!
That you mean?
It less than exists.
Yeah.
Okay. Now let's talk about symmetry. Talk about symmetry.
No, let's not.
Okay, symmetry.
Makes my job easier. I hate short guys.
You mean what?
Short guys.
I thought you said tour guys.
Okay. Look up here. I have drawn what looks like a mustache. I must ask you a question about this function. This one is even.
Yeah.
Even.
I just suck at
For the reason, because f of x, that means x is positive, that's on this side. Y value when x is positive, let it be this number, is equal to f of negative x.
Wait, what? Sorry.
F of x is equal to f of negative x. Look over here. This is going to be negative x. This is x and negative x. They're equal, the y values,
Also
right?
the area underneath.
Okay, so what's cool about that is let this be the area at negative a, and let this be the area under the curve at positive a. And if you're finding the area from negative a to positive a, negative a to positive a of f of x dx, a shortcut would be to double the area from 0 to a.
Oh.
See, it does make your life a little bit easier. So this is kind of cool. You could double the area from 0 to a if you know that you're dealing with an even function.
And if you're not, then good luck.
Okay, so you got options. It could be even, it could be odd. It could be odd. Let's draw up here, I don't know, a nice little sine curve. That's nice enough. Let's go from negative a to a. This is an odd function. Odd functions, by definition, have opposite signs at negative x values. So I am dealing with negative f of negative x,
Cancel out.
right? So if f of x happens to be 1, then f of negative x would be negative 1. They're opposite. Can you tell that? F of positive x is positive 1. F of negative x is negative 1. That's how they're odd. And this is a rule for that. F of x equals negative f of negative x. Okay. So what's the rule for the area under the curves?
Cancels out to 0.
Cancels out. If your function is odd, then the area under the curve from negative a to a of f of x dx, net change, right? Net change. I'm going to add up my aboves and my belows. Your net change there is 0. Your area cancels out. Now, the third option is neither, in which case you have lots of tools in your toolkit and you can evaluate. Questions on symmetry? Okay. So your hardest job on these is going to be proving that it's symmetric. But you know you want to go about that when you're dealing with the same limit. One's negative and one's positive. If you see the same number, you probably want to give this a try because it could very well go in your favor. Does that make sense? If I'm going from negative 2 to 2 or negative 7 to 7, even odd can really help you there. Sometimes it's neither, and then you have to go to work otherwise. This is going to be example 10. This is the last example for today. Symmetry simplifies. And we've got example A goes from negative 2 to 2 of x to the 6th plus 1 dx. We should try it. And there's nothing wrong with this. There's no u sub needed, right? You could go and evaluate from negative 2 to 2. You wouldn't be wrong. X to the 7th over 7 plus x on negative 2 to 2. Nothing wrong with that. But if I didn't have to subtract negative 2 to the 7th over 2, and I actually got to zero that piece out, that's faster. So let's see. What do you think? You think it might be even or odd? Even. It's got an even degree.
Yeah.
No chance it's odd.
What if it was?
Right? We got to remember polynomial functions. Either even ones look like this. We've seen this. Even. Okay, let's try even. So to prove that, we're saying f of x is equal to f of negative x. So we take f of x, which is x to the 6th plus 1. X to the 6th, sorry.
Oh, yeah, it is.
Equals negative x to the 6th plus 1.
It does do that.
What happens when I take negative x to the 6th power?
It
Gives me x to the 6th. So since those are equal, then we can say this is equal to 2 times the integral from of x to the 6th plus 1. So I have 2 times x to the 7th over 7 plus 1. Plus x evaluated on 0 to 2.
What's 2 to the 7?
128. 128 over 7 plus 2 minus 0. That's why it's so helpful. So 2 by 128 over 7. 2, let's call that 14 over 7. (128) plus 14. I'm looking ahead of you guys because we're in a hurry. That's 2 by 142 over 7. Final answer here is going to be 284/7. (284/7).
I take it that does not simplify.
No. Last one, y'all ready?
Yep.
Okay, I'm going to take a guess.
Odd.
Oh, it's probably odd. Answer 0. Yes. Okay, so let's go make sure. The function is tangent of x over 1 plus x squared plus x to the 4th dx. Like I said, guys, the hardest part here is proving that f of x is equal to negative f of negative x. So what I would do here is I would plug in that negative x and see if I get opposite things. On the bottom, that negative x is going to become positive. So my bottom is going to stay the same.
But the top just inverts.
What is tangent of negative x? So if I wrap around the other way with my tangent function.
It goes down.
Tangent is an odd function, right? Tangent looks like this. So what I have on the right side is opposite on the left. So this is equal to negative tangent of x, which means that my function is odd, which means that the integral from negative 1 to 1 of f of x is 0.
That was a lot easier than the one.
Yeah. The hardest part there is proving whether it's even or odd. Okay, that's all. I will have a circuit for you guys to practice starting tomorrow. Y'all want the night off? Yes. Okay, so come back and get a circuit from me tomorrow and we'll go to work with this stuff. That is the end of the unit. Your next test will be over use substitution.
Is that Monday most likely?
Most likely Friday.
Monday test.
Most likely Friday. I'll print those circuits and get them out to you as soon as possible.